Welcome back, class. Today we're going to be talking about properties of exponents, and more specifically, there's lots of properties of exponents, but today we're going to be talking about how to add and subtract exponents, and then we're also going to talk about how to multiply exponents. So we're going to kind of kill two birds with one stone today. When I'm talking about exponents, I'm talking about numbers like this, 3x squared. How do you add another number to 3x squared? So that's going to be the adding and subtracting part, and then in a little bit we're going to talk about how do you multiply 3x squared times another number. So before we can get too far into these properties of exponents, what we need to do is clear up some terminology and get the right vocabulary out there so you know exactly what I'm talking about when I talk about all these weird words. Okay, so the first thing that you need to know, and we've talked about it before so this shouldn't be too new, is the coefficient. So if you have a number like 3x squared, the coefficient then would be the 3. Okay, that's the number in front of the variable. That's the coefficient. Next, we want to talk about the base. The base then is the number that's being raised to a power. In this case, x is the one that's being squared. X squared. So x is the base. All right. Another term that we need to clear up is exponent. And your exponent is the number that your base is being raised to. So in this case, x is being raised to the second power. So my exponent is 2. All right, and then finally the last term that I want to make sure that you know what it is monomial. Okay, in monomial, mono means one, and nomial is like a term in math. Okay, so this whole thing here is one giant term, 3x squared. That's a monomial. A binomial, on the other hand, we're not going to talk about those today, but a binomial, bi means 2, so that would mean like 3x squared plus 5x. Okay, and so you'd have a 3x squared and you'd have a 5x, so that's a binomial. Today we're just going to worry about monomials, okay, and the coefficient, the base, and the exponent of monomials. All right, now that we've got that terminology out of the way, let's talk about how to add and subtract exponents. All right, when we're talking about adding and subtracting monomials, what we're really talking about is just adding like terms. And this is things you have done before, but I want to go over it one more time because when you add the exponent in there, it throws some students off. Okay, so I just want to cover adding like terms or adding and subtracting monomials one more time before we get into multiplying. What you need to know, the most important thing is that monomials can only be added or subtracted if they are like terms. Okay, you cannot add monomials if they are not like terms. You just can't do it. They can't be added or subtracted. So that's the most important thing that you need to know. Monomials can only be added or subtracted if they're like terms. Okay, so the steps. When you're ready to do this, you have like terms. The first thing you're going to do is add or subtract the coefficients. And then the next thing that you do is you keep the base and the exponent the same. So really, really easy, 2 simple steps. Add the coefficients, keep the base and the exponent the same. Okay? Now, again, like terms though, that means that both the base and the exponents are the same in both terms. You can't have the base be the same, like x and then x squared. Both of them have x for the base, but the exponents are different. Both the base and the exponents have to be the same in order for you to add like terms or add and subtract monomials. Okay, I hope that makes sense. Let's go over a couple of examples and then you have some to do in your notes. All right, I've got 3 quick examples here. And remember, there's no need to complicate this. All we're doing is adding like terms. Okay, so when I look at this first example, the first thing that I'm going to do is I'm going to look and recognize, see if I can figure out, are there any like terms up here? Okay, and remember that like terms have to have the same base and the same exponent. So as I'm looking at these, I've got a 2x squared and a 3x squared. Both of those have x as the base and 2 as the exponent. So those are like terms. I'm going to circle them. This other number, 4x, that term, it has the same base, but it doesn't have the same exponent, so it's not a like term. I cannot add that term to these other terms. Okay, so I found the two like terms. Now I go back to those steps. The step said add the coefficients, so 2 plus 3 is 5. And then it said keep the base and the exponent the same, so I'm going to keep the x squared. Okay? And then I can't forget about this 4x, so I just need to add that 4x. So the way that you simplify this expression is you combine the like terms. 2x squared plus 3x squared is 5x squared. And then you still have that 4x, so plus 4x. Okay? Just combining like terms. Example number 2, let's take a look at this one. I got to look for and see which ones have the like terms. So it looks like I have a 3y cubed minus a 2y cubed. I'm going to circle those terms. They look the same. Then my other terms, I've got a 4 and a 1. They don't have any variables with them, so those are like terms. I'm going to triangle those ones. There we go. So now I just add the like terms. I've got a 2y to the third minus, I've got a 3y cubed minus 2y cubed. So 3 minus 2 is 1y cubed, and you don't need to write that 1. In fact, it's kind of a waste to write that 1. So I'm just going to have y cubed. And then I add my other like terms. 4 plus 1 is 5. Okay, so 3 minus 2 is 1, and 4 plus 1 is 5. Adding like terms. One small thing that I should talk about is how to write your solutions. And the way that you should write them, just because it's the proper thing to do. If you would have wrote this one 4x plus 5x squared, like switch the order of them, it'd still be the right answer. It's just not like proper mathematics. Mathematicians always start with their highest exponent and work their way down to the lowest exponent. Okay, so like this one, I have an exponent of 3 here, so I'm starting with that, and then I work my way down to no exponent. On this one, I have an exponent of 2, and I work my way down to an exponent of 1. Okay, so when you write your solutions, you should start with the highest exponent and then work your way down, if that makes sense. It's just the proper way to do things. It's like the polite way to do math. All right, next problem. Let's look for the like terms. I've got x to the fourth, x to the fourth. Those look good. Then I've got x squared and an x squared. Those look good. So I'm going to combine the like terms. Again, I'm going to start with the one with the highest exponent, this one. So I have 4 minus 5. 4 minus 5 is negative 1, or negative x to the fourth. Then I look for my next one. 4x squared minus x squared. Well, 4 minus 1 is 3x squared. And that's my solution. That's how I add or subtract monomials. Okay, so there's 3 more examples for you to try in your notes to see if you have got this down. So you can pause this video and start those 3 problems, or if you'd like, you can wait till the end of this video and go back and try those 3 problems. In the meantime, we're going to move back to that second bird that we killed with the 1 stone. Okay, 1 video and 2 topics covered. So we're going to talk about multiplying monomials now. All right, multiplying monomials. This is also known as the product rule. Okay, and a lot of math teachers teach their students to memorize the product rule. You have to memorize this. I feel differently than that. I don't want you to memorize this. You don't have to memorize it as long as you understand how it works. Okay, so that's what I'm going to try and teach you today, is how it works rather than memorize this. Okay, because once you know how it works, You don't have to memorize it. You just know how to do it because you know how it works. All right, so multiplying monomials. This is how you multiply monomials with like bases. Okay? 3 simple steps. First, you multiply the coefficients to get your new coefficient. Second, you keep the base the same, leave the base. And third, you add the exponents to find your new exponents. Okay? So this is what most math teachers ask their students to memorize. Okay? And I'm okay if you don't memorize this. It's good to write it down so that you can look back at it and say, oh yeah, I forgot to keep my base the same, or things like that. But I don't need you to memorize this. Let's just learn how it works. Here's some examples. All right, so in example number 1, we have 2 monomials that we're multiplying together. 3y squared times 2y. Okay? And let's break this down and think about what this problem really is saying. Okay? It's saying 3 times y, 3 times y squared. And y squared, if you remember back, y squared is y times y. Okay? So 3 times y times 2 times y. Okay, see that? 3y squared. 3 times y times 2 times y. So really this is just one long multiplication problem. And remember, multiplication doesn't matter which order you multiply things, just that they all get multiplied. So what I'm going to do is I'm going to take my numbers, my 3 and my 2, and multiply those. 3 times 2 is 6. Okay, and that's step 1 from the notes that we just took. Step 1, multiply your coefficients. Step number 2 is keep your base the same. So since my base is y, I'm just going to keep y. I wouldn't want to change it to an x. Okay? And since I've got 3 y's now, y times y times y, that's really saying y to the third. Y times y times y is y to the third. So my solution then is 6y to the third. And again, we just follow the steps. If your base doesn't have a coefficient, or excuse me, if your base doesn't have an exponent, then your exponent is just 1. Okay, so really what we did is we did 2 plus 1 to give us the 3. Okay, but we knew how it worked. Y times y times y is y to the third. Okay, so let's do example number 2 real quick. 2x squared times 2x to the third times y to the fourth. If I had to break this thing down, break it apart, okay, really what it's saying is 2 times x times 2 times x times x times x times y times y times y times y. I ran out of room there. It's a lot of y's and x's. Okay, that's what this problem is really saying. So I'm going to take my coefficients and multiply them. 2 times 2 is 4. Okay, and then I'm going to count up all my x's. I've got 1, 2, 3, 4, 5 x's. If you don't want to write all those down and count them, then you can just look up here. 2 plus 3 is 5. That's how I got it. Okay, and then I'm going to add up all my y's. 1, 2, 3, 4. Okay, and if you don't want to write down all your y's and count all your y's, then just look. I've got y to the fourth and no other y's, so I must have y to the fourth down here. And this is my solution. 4x to the fifth times y to the fourth. Okay, makes sense? One last example, then I'll cut you loose on your own. This one down here, let's try it without writing everything out. Okay, let's try it without writing everything out. We take our exponents, we multiply them. I said exponents, I'm really sorry. Not exponents, these are your coefficients. Take your coefficients and multiply them. 3 times 2, 6. Now I take my exponents and I add them. Okay, so I look at my x's, I've got an x to the fourth here, and an x to the third here. So I'm going to keep my base, keep my x, and add my exponents. There we go. Then I look for my y's. Keep my base, keep my y, and then add the exponents. 2 plus 2 is 4. So 6x to the 7th times y to the 4th. That's the solution for that, that monomial times monomial. The solution is 6x to the 7th, y to the 4th. All right, you have 3 more examples of those to try in your notes also. Try those 3 examples, see what you get, and if you have any questions or you have ones that are hard for you, circle those, put a star next to them, write a little note so that we can talk about those in class. Thanks a lot for watching. I hope this comes easy to you. Bye.